In this session of work, energy and power, we are going to apply the concept of work kinetic energy theorem. Now, first of all, we are going to revise the concept of work kinetic energy theorem, and work kinetic energy theorem will be given by work done equal to final kinetic energy minus initial kinetic energy. This one is the work kinetic energy theorem, right? And that we have discussed in the previous sessions. Now we are going to revise the concept of work done by the spring force, and this concept was discussed in the previous session. The work done by the spring force, if this spring is extended from the position x1 to position x2, will be given by minus half k x2 square minus x1 square, right? Now we are going to discuss a very important problem. Consider this block, and this block has the mass m, which is suspended by an ideal spring that you can see. We have to find the maximum extension in the spring, right? The spring constant of the spring is k, and the spring is ideal. Ideal spring has very negligible mass, and initially the block is released from rest. This block has the mass m, and the spring has the spring constant k, and we have to calculate this maximum extension in the spring, and let it be denoted by x. For this problem, we are going to apply the work energy theorem, and using the work energy theorem we can find the maximum extension in the spring, right? According to the work energy theorem, total work done will be equal to change in kinetic energy, that will be equal to half mv square minus half mu square. Now, when the block is released from rest, that means at this position the block has the speed 0, and when the spring will have the maximum extension, at this moment the block has the speed 0. That way we can say that the final kinetic energy 0 and initial kinetic energy 0. That means these two quantities are 0, and hence total work performed by different forces, that will come out 0. Now our main concern is that what are the different forces which are performing work. For this we are going to draw the free body diagram of this block, and the free body diagram of this block will be weight mg, which will act vertical downward, and the spring force which will act upward, and this spring force will be given by kx, right? Now we have to find the work done by the weight mg. As the extension in the spring is x, that's why the block has the displacement x, and hence the work done by the weight mg will be equal to mg into x, right? Now we are going to find the work done due to the spring force, and as we know that the work done by the spring force is given minus half kx square. Hence the total work performed by different forces will be the algebraic sum of these two, and these two will be equal to 0, right? Now by doing very simple calculation, we can say that x will be equal to 2 mg divided by k, right?